Hello, this is Mrs. Hilt here with Newton's second law of motion lesson. Newton's second law of motion is the law of acceleration, and it is often stated that when an unbalanced force is applied to a mass, it causes it to accelerate. So the object of these notes will be to understand the relationship between force, mass, and acceleration, and how to calculate each of those given the other two. Okay, so how do all of these, and by these I mean unbalanced force and mass, affect acceleration? So we're going to look at it in two different comparisons. The first will be comparing an unbalanced force to a non-changing mass and seeing what the resulting acceleration will be. So the object that we're going to use is a football, and we're going to see two different unbalanced forces applied to the football and see what the resulting acceleration is. Okay, so first we have a Pee-wee football kicker.
Oh.
Okay, so one type of force was applied there, and let's see another force.
Here we go.
He hit it! Yeah!
All right, sorry, I thought the sound would be muted on those. But we had two different forces, two unbalanced forces, which resulted in acceleration. The force for the mini packer was a much lesser force, therefore causing a much lesser acceleration. And for J.K. Scott at Mullen, he had more of a force, which resulted in more acceleration. Therefore, the magnitude of an unbalanced force is directly related to the acceleration of the object. So it's the type of relationship where one goes down, or one goes up, the other goes up. One goes down, the other goes down. Next, we are going to compare mass to the acceleration when the force is held constant. Okay. So for this example, it's going to be another video, and he will explain what's going on.
How this works. I have two objects. One is red and one is yellow, and that's neither here nor there. But this one is heavier, and you're gonna have to take my word for it. I've got something inside the red ball, which does make it a bit heavier, and there's nothing inside the yellow ball. So I have two different masses, a heavier one and a lighter one. And I draw your attention to our high-powered air cannons, which I have here on the stage. Now what I'm gonna do is I'm gonna try and move these, accelerate these objects across the stage, using exactly the same amount of force. So I'm going to put one of our objects, the heavier one, here, and our lighter object here. The force is going to be exactly the same behind each object. So I'd ask you, which one do you think would go faster and farther? Again, the force is the same, but our objects have different masses. If we look at that second law of motion, it says the strength of a force is equal to the amount of mass involved multiplied by the acceleration. I don't want to give anything away, but let's actually try this. Now, I've done something a little risky here, which is I'm pointing them at Parnelli, who delivers our programs here, has graciously accepted the job of tester for this. I've loaded him up, and we're going to fire these directly at Parnelli, and he's going to see which one is going to travel faster and farther. You okay with this? You're good? Good, because your contract says you're allowed to do this. So we're going to arm our system. We're going to put in some air pressure, so there's enough that should be more than enough. And we're going to do a quick countdown and fire these at our brave volunteer and see which one is going to travel faster and farther. All right, we're going to go 3, 2, 1, and could you tell which one was going faster and farther?
I had my eyes closed.
I did notice that you had your eyes closed, but I can tell you without a doubt the yellow one, the lighter one, was going faster and farther. So, what did we have? The yellow one. The yellow one went faster and farther than the red one because, of course, it's lighter. It takes less force to move something that's lighter. Now, not only do we see this in rockets, you want to have a nice light rocket to go into space, you actually see this in everyday life. With the price of gas going up, you'll notice people are trading in their heavy trucks for lighter cars because it takes less force to move that lighter object. So again, something that we're going to be seeing a lot more of. If that price of fuel keeps increasing, we want to try and find a really efficient way of moving ourselves around. For the Express here at the H.R. MacMillan Space Center, I'm Cam Cronin. Thanks again for...
All right. So with the same force applied, the yellow ball, which was lighter, accelerated faster, and the red ball, which was heavier, accelerated slower. Now I want you guys to try and think about what we could fill in these blanks, and it is not their less or more mass. Think about a keyword from unit or the last PowerPoint, Newton's first law, and what could possibly go there. Pause the video, think about it, and press play when you're ready for the answer. All right, that word that I was looking for was inertia. The red ball had more inertia, therefore it had more resistance to change its state of motion, and that is all because it has more mass. All right, now let's get into the calculations. So whenever you're calculating force, mass, or acceleration with Newton's second law, this is the formula that you guys will use. F equals ma. And the units that are applied to each of those are shown, and that's actually why 1 Newton is equal to a kilogram times meters per second squared, because a Newton is calculated, or force is calculated, by multiplying mass by acceleration. All right, we're going to go through an example calculation for solving for each variable of this equation. Frank pulled his 24 kilogram son, George, on a sled at a rate of 1.7 meters per second squared. What was the amount of force Frank exerted to pull George on the sled? I want you guys to try pausing your video and calculating the force given this mass and acceleration. When you're ready for the answer, press play.
When solving for force and mass and acceleration are given, the calculation is very straightforward. Just be force is equal to the mass in kilograms times the acceleration in meters per second squared. Just multiply those two together and you will get 40.8 newtons. And if we round that to sig figs, that would be 41 newtons. Okay. And how that would look with dimensional analysis, we would have our mass. We'd have our mass times our acceleration, 7 meters per second squared, which would result in the 41 kg times m over second squared, which is equivalent to the 41 newtons.
All right, next one is solving for mass. Elaine pushed Kramer, who was wearing rollerblades, with a force of 200 newtons. Kramer accelerated forward at 3.2 meters per second squared. What is Kramer's mass? And for this problem, we are assuming that no other forces are acting upon Kramer, so nothing like friction or air resistance, so don't let that throw you off. Pause your video, try this calculation on your own first. When you're ready for an answer, press play.
Calculating for mass given force and acceleration. One way that you could do this is with dimensional analysis. So let's first plug in our force, 200, and I'm going to write it kg m over second squared, which that is the same units for newtons, just more spelled out. And we will end up taking our acceleration and the 200 and the 3.2 will end up being divided. 3.2 meters 1 second squared, because that cancels out meters, second squared, resulting in our kilograms being carried all the way through. And when we divide that out, that would be 62.5 kg. Okay, so that's how the units end up working out. You can also solve this problem by taking your force and dividing it by acceleration. And that would also give you the 62.5 kilograms.
All right, one more, and that will be for solving for acceleration. Jerry threw a 8-kilogram loaf of bread to George with a force of 76 newtons. What was the acceleration of the loaf of bread? Again, try pausing the video and attempting to solve this one on your own. When you're ready for the answer, press play.
Solving for acceleration given force and mass. This will look really similar to solving for mass, and I'm going to show you first with dimensional analysis. Going to write out the units for force, the full units, there we go, so that we can really see where the acceleration units are. And those are right here. So I know that those have to carry through to the end. So my next step is placing my mass in the proper spot so that the units cancel out. So I would have to go down here. Kilograms, cancel out. So 76 divided by the mass, or the force divided by the mass, is equal to acceleration. So 76 divided by 8 is 9.5 meters per second squared.
All right, if you guys have any more questions, please shoot me an email. Thank you guys for watching, and see you for Newton's third law. Bye.